Welcome to the DIY Honda Garage channel. Welcome to this troubleshooting presentation for the DTC P0530-16, which indicates an AC pressure sensor circuit low voltage issue in the Honda CR-V 2023 and newer models. This specific diagnostic trouble code, DTC, informs us that the output voltage from the AC pressure sensor is below acceptable levels as determined by the Powertrain Control Module, PCM. Located within the AC system, the AC pressure sensor is crucial for monitoring the refrigerant's pressure, ensuring the AC system operates efficiently. If this sensor fails or its circuit has issues, it can lead to inconsistent cooling and potential damage to the AC components. Throughout this presentation, we will delve into the detailed diagnosis and troubleshooting steps to resolve this error, restoring functionality to your vehicle's air conditioning system. The AC pressure sensor plays a vital role in the operation of the air conditioning system by monitoring the refrigerant pressure and sending this information to the PCM. Specifically, it detects low-voltage scenarios that could indicate a problem with the sensor or its circuit. The sensor is typically located in the AC system, making it readily accessible for inspections. Other components reliant on this sensor's input include the compressor and the overall AC control module, as they depend on accurate pressure readings for optimal performance. Failure in this circuit can lead to overheating, lack of cooling, or even damage to the AC compressor due to incorrect pressure readings, significantly impacting the vehicle's comfort features. Several factors could lead to the DTC P0530-16 being triggered. Firstly, a faulty AC pressure sensor may fail to send the correct voltage signal to the PCM, resulting in low voltage readings. Next, issues within the external circuit wiring, such as open or shorted connections, could disrupt communication between the sensor and the PCM. Furthermore, the PCM itself could develop faults that impair its readings or responses based on input from the sensor. Lastly, any damage or corrosion within the external wiring can lead to poor electrical conductivity, triggering a low voltage error. Understanding these causes helps streamline the troubleshooting process to identify the root of the issue efficiently. When the DTC P0530-16 occurs, you may notice several symptoms indicating a problem within the AC system. One of the most apparent symptoms is inconsistent AC performance, where the air conditioning fails to maintain the desired temperature. Additionally, the compressor may cycle on and off excessively due to erroneous pressure readings, leading to inefficient cooling or overheating. Furthermore, dashboard warning lights may appear, alerting the driver to a potential malfunction within the system. Addressing these symptoms promptly is crucial, as neglect may lead to further damage to the HVAC components, incurring higher repair costs. To begin troubleshooting DTC P0530-16, start by turning the vehicle to the on mode. This ensures that all relevant systems are powered and ready for testing. Next, activate the blower switch to establish air circulation, followed by turning on the AC switch. This will allow the AC system to operate while you monitor the AC pressure sensor's voltage readings. Using the Honda Diagnostic System HDS, check the AC pressure sensor voltage value to see if it measures less than 0.24 volts. If so, this indicates that the failure condition has been duplicated, and further detailed inspections must follow to determine the underlying cause of the low voltage signal. The next step in the troubleshooting process involves inspecting the AC pressure sensor itself, along with the external circuit connected to it. First, disconnect the AC pressure sensor connector, which is typically a 3-pin 3P connector. Begin by testing the sensor's voltage output in normal conditions. You should expect approximately 5.0 volts when the vehicle is on. If the voltage is normal, but the DTC persists, the fault likely lies with the sensor itself. If you find abnormal readings, investigate the external wiring and connections, which could reveal open or shorted circuits affecting the sensor's operation. In this step, proceed with a VCC6 inspection while ensuring both the AC pressure sensor connector and the PCM connector are disconnected. Before disconnecting the PCM connector, jump the SCS line using the HDS for safety. Assess the circuit by checking for open wire conditions, which should ideally measure less than 1 ohm. If any abnormalities are noted during this test, it indicates potential circuit damage that needs further inquiry. Additionally, conduct a check for any short circuits in the PD sensor line, which should measure more than 1 mega-ohm when tested correctly. Discrepancies in these readings could confirm underlying problems affecting the signal strength. As we reach the final step of the troubleshooting process, inspect the powertrain control module, PCM, rigorously. This is critical, especially if earlier inspections have ruled out the AC pressure sensor and external circuits as causes of the DTC. If both components check out as normal, it is reasonable to conclude that the PCM may be faulty and therefore the source of the malfunction. Test the module according to manufacturer specifications, confirming it correctly interprets sensor data. If a malfunction is detected, plan for a PCM repair or replacement to resolve the DTC and restore AC functionality. Final repair verification is crucial to ensure that the issue causing DTC P0530-16 has been adequately resolved. First, reconnect all previously disconnected connectors, including the AC pressure sensor and PCM connectors. Once reassembled, run a function test by activating the AC once more to examine whether its performance meets the expected conditions. Confirm that the voltage readings from the pressure sensor fall within the normal range. Lastly, clear the DTC from the PCM using the HDS and perform a drive cycle to monitor if the DTC reoccurs. Successful completion of these steps indicates the issue has been rectified, returning reliable AC system performance. After resolving DTC P0530-16, employing preventive maintenance tactics can help avert future issues with the AC system. Conduct regular inspections of the AC system, paying specific attention to the AC pressure sensor and its connections. Monitoring refrigerant levels consistently will ensure that the system operates effectively and that potential problems can be addressed before escalating further. Periodically, check wiring and connectors for signs of wear or corrosion, as these can compromise system operation over time. Implementing these practices will prolong the life of the AC components and reinforce overall vehicle reliability. In conclusion, understanding the DTC P0530-16 related to AC pressure sensor circuit low voltage is vital for maintaining optimal AC system performance. Identifying the primary causes of this issue, including sensor faults, circuit integrity, and assessing the PCM, equips technicians with the necessary insights for effective troubleshooting. Regular inspections, along with proactive measures, ensure timely detection and resolution of potential concerns. Ultimately, maintaining the functionality of the AC system contributes significantly to vehicle comfort and longevity. By following the outlined steps and preventive measures, technicians can provide excellent service and ensure the reliability of the Honda CR-V 2023 and newer models. Please like and subscribe to the channel. See you next time.